we're going to talk about circles, and we want to start with the geometric definition of a circle. A circle is the set of all points in a plane that are a fixed distance from a point called the center. That fixed distance is called the radius of the circle. That's the geometric definition of a circle. We need to know something algebraic about the circle if we're going to have any chance of working with it. So we're going to need to know what its equation looks like. The standard equation of a circle, whose center is at the ordered pair we're going to just for now call h comma k. H is going to represent the x value of the center, and k is going to be just what we call the y value of the center. That equation will always look like this. Parentheses x minus h, so x minus whatever the x value of the center is, squared, so that whole thing squared, plus parentheses y minus k, so you take y minus whatever the y value of the center is, square that, and that will always equal the radius squared. That's the equation of a circle. And if you want to graph a circle, that's the equation you use to find all the different points that are actually on that circle. This little formula here, the standard equation of a circle with center at hk, it works technically for everything, but it's also for any circle, no matter where it's centered, but it's also good to recognize if a circle is centered at 0, 0, what that would look like. So imagine for a minute that I put 0 in for h and 0 in for k. Let's say this circle is centered at the origin. What happens is this little parenthesis collapses. X minus 0 is just what? So the parentheses disappear and it just becomes x squared. And the same thing happens to the y value. Y minus k, quantity squared. Y minus 0 would be just y squared. So if you see a circle that's just x squared plus y squared equals a number, if you see that equation, that means that that circle is centered at 0, 0. And you need to recognize both just very quickly. Those are sort of the general idea what they will look like. If it's not at 0, 0, you will see the parentheses squared. And notice there's a plus sign in the middle, not a minus sign. If you ever see one with a minus, it's something else entirely. And we may be able to get there in December or so. Maybe not, we'll see. But the circle has to have a plus here and here. So let's look at this example. We are asked to find the center and radius of the circle with the equation x minus 3 quantity squared plus y plus 2 quantity squared is equal to 36. So you should sort of recognize the pattern there. Can anybody tell me right off what the center is? It's 3, negative 2. The way the formula is given, it's x minus h, which means basically it's going to be the opposite of what it appears. And if people are going to struggle with circles, that's what it's going to be. They're going to get that center backwards, so try not to do that. The way I usually tell it is this. The center is what makes the parentheses 0. So to make it 0, I would need positive 3 and negative 2. So it's the opposite of what you think it is. It's what makes those parentheses collapse to 0. So the center is positive 3, negative 2. And the radius is the square root of this constant right here. So in this case, it's positive 6. And the radius will always be positive. So that's that example. So usually people do really, really well with that. But now, let's go the other way. I'm going to give you the center and the radius, and I want you guys to write the equation. So write the equation of the circle that has a center at negative 2, positive 4, and a radius of 1. I'll pause for a second and see if you guys can get it. Okay, what do we have? What'd you guys get?
X plus 2 squared.
X plus 2 squared plus
X minus 4 squared.
y minus 4 squared equals what? 1. Yeah, 1 squared is still 1. So when you put it back in, you have to remember that it's x minus h. So this is your h, this is your k. So x minus negative 2 is plus 2, y minus positive 4. And then don't forget the squares and the plus in between. And don't forget to square your radius. With 1 it didn't matter, but with other numbers it would. So a lot of little mistakes are made there. Just be very, very careful and double check it when you're finished.
Okay, it can be on camera or recording or whatever. Okay, so when you're writing the equation of a circle, like, do you have to put it as like 6 squared or like just write it as 36? Like,
Oh no, you could write it just as 36, definitely.
Okay,
you
I
would
was just wondering.
you would always simplify.
Okay.
So for example, if you had a radius of like r equals 2 square root of 5. Well, to square that would be 2 square root of 5 all squared, but you wouldn't leave it like that.
Okay.
You would actually change it to 20. And so that's what would be on the right side. So you do simplify it that way.
Okay, I was just wondering.
That's a good question. Okay, now we want to introduce the general form of the equation of a circle. And I'll go ahead and tell you it's a terrible form, it's not very useful, and it causes a lot of problems, but you still have to learn it. So be prepared. General form is where we take the equation and we square, double square the two parentheses, and we get rid of all the parentheses, we write them all out, we get it equal to 0, and we put it in a certain order. It's very picky. It goes in this order. First you put the x squared, then you put the y squared, then you put your linear x's, then your linear y's, then your constant equal to 0. So it takes forever, and it's not useful, because once we do that, we're not able to visualize and see the radius. We're not able to visualize and see the center. So you lose everything that you can tell about it. So we don't like this form, but we have to be able to work with this form, because if it's given in that form, we're going to have to learn to go backwards and convert it to standard form. So make sure you know the difference. For the next example, we're going to actually find the general form of the equation of the circle with a radius of 5 and a center at 3, 2. If we want to put this in general form, we're going to have to start with standard form. So let's start there. For standard form, we know that that's going to be x minus 3 squared plus y minus 2 squared equals what?
25.
25, 5 squared. So that's going to be 25. From there, I need to square, double square both of those parentheses, and then I need to move the 25 over to the left. So let's start with this one. This will become x squared minus 6x plus 9 plus y squared minus 4y plus 4 equals 25. Any questions up to that point? We're good? So now we need to start going through, putting it in the right order and collecting our like terms. So I have an x squared and a y squared. So there are our first two terms. Then I want to put all of my plain x's. So how many do I have?
-6.
-6. So the -6 is technically acting as that c right there.
Okay.
Then we're going to put the plain y's, -4y, and that's technically acting as our d, -4. And on the left right now, I have positive 13 for my constant, and that's equal to 25. But I'm not finished yet. It's not considered in general form until it's equal to 0. So now I need to just move the 25 to the other side. And that gives me x squared plus y squared minus 6x minus 4y minus what?
12.
Minus 12 equals 0. So my e value for this particular equation turns out to be
-12.
-12. When you look at the equation in that form, in general form, you can't tell anything about it. You do not know, you hardly even know it's a circle. I mean, that's how hard it is to recognize. It's only the x squared plus y squared that actually gives it away. You can't tell the center, you can't tell the radius, so it's a very useless form of it. However, if I give you that form, I need you to be able to go backwards, and that's what we're going to do for the remainder of this. We're actually going to work backwards. I will give you general form, and I will teach you how to put it in standard form so that you can find the center and the radius.